Hello everyone, my name is Kaushiki Chaparia, and on behalf of my co-authors, I would like to present my work on spectral spatial classification network for hyperspectral images using a residual attention network. So the main motivation for our work was to enhance the spectral and spatial features for the hyperspectral images and to optimize the parameter for CNN-based HSI classification. Uh, for this work, the main state of the art was we have introduced a two-branch spectral spatial residual attention network, which we have termed as S-square RANHC for hyperspectral image classification. In the first block, it's a feature extraction and classification network, which consists of four convolution net layers, BN, max pooling layer, and ReLU to learn low-level features. And in the second block, it is a residual network along with skip layers to overcome the vanished gradient problem without increasing the feature operation. So this is our proposed framework. And the block consists of four convolution layers. To learn high-level joint spectral spatial features, fully connected layer is used with the softmax function for prediction and classification. And to extract features of different sizes and ratios, convolution neural network with 3 cross 3 kernel size and a 5 cross 5 kernel size is used. Uh, the residual network has been explained over here. In the residual network, the idea was to construct a deeper neural network to overcome the vanishing gradient. It consists of 1 cross 1 convolution layer to perform cross-channel pooling and a Gaussian dropout to keep the expected value of activation unchanged. The Gaussian dropout, unlike the regular dropout, does not require weight scaling during inferencing, thus providing a computational advantage. This is the quantitative analysis of our work done. We have considered three different data sets, which is Indian Pine, Botswana dataset, and Pavia Center. We have compared our result with different state-of-the-art methods, considering from the traditional method just such as support vector machine and three-dimensional convolution neural network to other residual or attention network that has been the state-of-the-art in the deep learning network. And we can see the overall accuracy and the kappa coefficient for our proposed work is specifically much better than other compared state of the art. This is the qualitative analysis for Indian pines with other state of the art method, where you can see the B is the ground truth, and from C to J is a different classification map, and J defines the proposed method. This is qualitative analysis for Botswana dataset, and same for the PVR Center. To conclude our research work, the proposed model, which is S-square RANHC, consists of a residual block and a feature extraction module, helps in selecting the most effective spectral bands and focus on increasing the spatial information for their nearby pixels. Compared with other residual attention model, the proposed model achieves better classification accuracy even with limited number of training samples. The experiment result on three different data sets proves the state of the art for various land use, land cover scenarios, and thus can be generalized to other remote sensing datasets. The future work is aimed at to observe the effect of training samples and patch sizes and the effect of attention network, to calculate the training and test time for computing network efficiency with respect to accuracy, and to test the model on a large hyperspectral datasets having more complex features. These are the references that has been used for our research work. Thank you. Thank you for your attention. And if you have any questions, please feel free to ask.